Most people think black holes are giant cosmic vacuum cleaners that swallow everything around them. But is that actually true? Imagine you're floating in space. Ahead of you is one of the most terrifying objects in the universe, a black hole. You might expect it to instantly suck you in from millions of kilometers away. But surprisingly, that's not how black holes work. In fact, one of the most common things people believe about black holes is completely wrong. So today, let's answer the question: do black holes really swallow everything? To understand the answer, we first need to know what a black hole actually is. A black hole can form when a very massive star reaches the end of its life. After burning through its fuel, the star can no longer support itself against its own gravity. The core collapses and collapses and collapses until an enormous amount of mass is squeezed into an incredibly tiny region of space. The result is a black hole, a place where gravity becomes so strong that not even light can escape. Around every black hole is an invisible boundary called the event horizon. Think of it as a point of no return. Cross this boundary and escape becomes impossible. But here's something important. Black holes are not magical objects with infinite reach. They are governed by the same laws of gravity as everything else in the universe. And that brings us to the biggest misconception. Many people imagine that if the sun suddenly became a black hole, Earth would be pulled in and destroyed immediately. But that's not true. Surprising fact number 1, if the sun magically turned into a black hole while keeping the same mass, Earth would continue orbiting almost exactly as it does today. Why? Because gravity depends on mass and distance. If the mass stays the same, the gravitational pull stays the same. Earth doesn't orbit the sun because it's a giant glowing ball. It orbits because of the sun's mass. Replace that mass with a black hole of equal mass, and Earth's orbit would barely change. Of course, we'd freeze without sunlight, but we wouldn't be swallowed. So, if black holes don't automatically suck in everything, why are they so dangerous? The answer is simple. You have to get too close. As you approach a black hole, gravity becomes stronger and stronger, but it doesn't pull equally on every part of your body. Your feet, being slightly closer to the black hole, experience a stronger gravitational pull than your head. This difference is called a tidal force, and it leads to one of the strangest phenomena in the universe: spaghettification. Yes, that's the real scientific nickname. As tidal forces increase, you should be stretched longer and longer while being squeezed thinner and thinner, like a noodle. Not exactly the kind of pasta anyone wants to become. Surprising fact number 2, for some supermassive black holes, you might cross the event horizon without noticing any unusual at first. That's because larger black holes can have weaker tidal forces at the event horizon than smaller ones. The real danger may only appear much deeper inside. But here's an even bigger question. Could black holes eventually swallow everything in the universe? Science fiction often portrays black holes as unstoppable cosmic monsters that consume entire galaxies. Reality is much less dramatic. Black holes can only capture objects that come sufficiently close. Most stars, planets, and galaxies are incredibly far apart. Space is enormous. Even our Milky Way galaxy contains hundreds of billions of stars spread across unimaginable distance. Stable orbits can exist around black holes just as they exist around stars. In fact, some stars are known to orbit black holes for years without falling in. Surprising fact number 3, black holes don't just grow forever. According to prediction by physicist Stephen Hawking, Black holes slowly lose energy through a process known as Hawking radiation. Over incredibly long periods of time, black holes may eventually evaporate. So no, black holes are not destined to consume the entire universe, and that's what makes them so fascinating. They are not giant vacuum cleaners sweeping through space. There are regions where gravity becomes so extreme that our everyday intuition begins to fail. Black holes aren't cosmic vacuum cleaners. They are something far stranger. They can bend space and time, trap light itself, and challenge our understanding of reality. The more we learn about them, the more mysterious they seem. And somewhere out there, hidden in the darkness between the stars, countless black holes continue shaping the universe in ways we're only beginning to understand. Maybe the most fascinating thing about black holes isn't what they swallow. It's how much they still have left to teach us.